Jupiter is a major planet in our solar system. Not only is it the largest in mass and size, but its influence can be seen throughout our entire solar system. If we talk about Earth, this planet acts like a shield for our planet. Any object coming from outside has to pass through Jupiter's intense gravitational pull, which changes the path of objects heading towards Earth and saves our planet from another terrible disaster. How many times has this giant planet of the solar system, Jupiter, saved Earth and human civilization? We probably can never count that. But humans have always been amazed whenever they look at this planet in the sky. From Galileo's first observation of Jupiter to today, we have certainly learned a lot about this planet. From a faint dot, we have peered deep inside Jupiter. During the Voyager mission, Jupiter was studied up close. But just this much is not enough to know and understand this giant planet. When dedicated missions have already been planned to study Pluto and Saturn, how could Jupiter escape scientists' notice? Where dedicated missions have been planned to study Pluto and Saturn, how could Jupiter remain unknown? Almost none. The fact that our civilization knows almost nothing about Jupiter, which is balancing the entire solar system, could be dangerous for us. After all, what role does Jupiter play in our solar system? Is it much more important than we think? What's happening inside it? Is there life on its moons? There are many such questions that still force us to look at Jupiter with a sense of wonder. And to find answers to these questions, the European Space Agency launched a mission called Jupiter Icy Moons Explorer, or JUICE, on April 14, 2023 from French Guiana. This mission is truly remarkable, and its scientific objectives will also give a new direction to human civilization. Our science will reach a whole new level, but today, in this video, we will not be discussing this mission. But there is another thing in this entire mission that I found very interesting. When I was reading about this mission, I came across this timeline. It's been about 5 months since this mission was launched. Currently, it is orbiting the Earth. After about 1 year and 4 months, that is, in August 2024, it will reach the Moon, and from there, using gravity assist, it will do a flyby of Earth again in the same month and head towards the planet Venus. Then, about a year later, on August 31, 2025, it will reach Venus. From there, it will perform another slingshot maneuver, its speed will increase, and by September 2026, it will do another flyby of Earth. Then it will go into a large elliptical orbit. After about 2.5 years, on January 18, 2029, it will pass close to Earth again, but this time, it will be different. It will leave Earth's orbit, cross Mars' orbit, pass by an asteroid named 223 Rosa in the asteroid belt, and then enter Jupiter's realm. But by then, July 2021 will have arrived, and then it will study the rest of Jupiter's systems. Now, just looking at this timeline feels strange. Why does it take 8 years for a spacecraft to reach its destination even under ideal conditions? To put it simply, why is it taking the JUICE mission 8 years to reach Jupiter? Whereas earlier, the Voyager mission reached Jupiter in less than 2 years. Besides, the New Horizons spacecraft took less than a year to reach Jupiter. So then, despite having advanced technology, what is it about the JUICE mission that it's going to take so much longer to reach Jupiter? So this will be the topic of our video today. To be honest, make sure to watch the video till the end. It's about 600 million kilometers, but in these 5 months, JUICE has already traveled about 370 million kilometers. If we look at it in terms of time, this mission hasn't even completed 1/5 of its cruise time yet. That's because the distance we've calculated between Earth and Jupiter is a straight line, but our spacecraft is actually following a particular trajectory. So the question that arises here is, why is it like this? The answer depends on several things, like the power of the rocket, whether we can go straight towards Jupiter or not, and why do we waste so much time? The weight, the amount of fuel, and the geometry of the planets, all these things decide how we have to reach a specific planet. Look, orbital mechanics is a field where anything can happen at any time. For example, despite having a lot of fuel, Luna 25 was not successful, but even with less fuel, the Chandrayaan mission became a big success for India. Here, with a little patience and a lot of planning in orbital mechanics, if needed, we can get out-of-the-box results. Sometimes we need to think out of the box, because in space, everything, whether it's planets or moons, and even larger structures, everything here is in motion. When we launch a mission, it's not launched from a still Earth, but from the Earth, which is orbiting the Sun at a speed of 30 kilometers per second. In such a situation, targeting your mission from one moving object to another moving object is a complicated task. When Earth and Jupiter are on opposite sides of each other, the distance between them can reach up to 968 million kilometers. But when these two planets come closer in their orbits, this distance comes down to about 600 million kilometers. But this position and this minimum distance only last for a few moments, and after that, the distance starts increasing again. Another problem is that each planet is orbiting the Sun at its own speed. That means the engineers will have to calculate the entire trajectory of the mission with complete accuracy, because in this empty space, we have to launch our mission in such a direction where, right now, there is no planet there, but as soon as the mission reaches the orbit of that planet, the planet, moving at its own speed, will arrive there. Now imagine that you have a powerful rocket. You launched it on the trajectory with the shortest distance, and that too at the right time. Now, how long will it take you to reach Jupiter? You would want to reach Jupiter as quickly as possible, but still, it will take you at least 1 to 2 years. As we saw earlier, it took Voyager about 2 years and New Horizons about 1 year. Now, the problem with going to Jupiter is that the missions we are taking as examples only had to fly by Jupiter. They didn't have to stop there. Now, if you've already made the mistake of going to Jupiter at this speed, then think about how you'll stop at Jupiter without brakes. How? So here comes the concept of orbital mechanics, which we are discussing. When this energy becomes more negative, satellites start falling towards the Earth, meaning when satellites lose energy, to prevent them from crashing into the Earth, their orbital energy is increased by firing the thrusters, but when the orbital energy increases too much, the objects leave the orbit and move away. So now the point here is that the speed with which you are heading towards Jupiter, you will have to lose that kinetic energy. And to do this, you can fire the thrusters in the opposite direction. This will waste a lot of fuel, and to carry that much fuel, you will also have to waste a lot of fuel at launch. And the second thing you can do is reach there with less speed without wasting so much fuel. But for that, you'll have to compromise on time. But in this, we will also get time to maneuver and manage the spacecraft if the speed is low. One thing is clear from here, the weight of the spacecraft plays a crucial role in how much time it will take to go anywhere. Because more weight not only increases the cost of launching, but also increases the cost of inserting into orbit after reaching the destination. Also, a more powerful rocket is needed to launch more weight. Now, increasing the weight of the spacecraft by adding more fuel not only makes the launch difficult, but also increases the complexities of the mission even more. While launching from Earth, we have to provide the spacecraft with a specific minimum velocity, which we call escape velocity, so that the object can get out of Earth's gravitational pull. If we talk about the JUICE mission, it is the heaviest interplanetary mission so far, with a weight of more than 6,000 kg. To launch it, one of the most powerful rockets, the Ariane 5 heavy lift rocket, was used. But even this rocket was not powerful enough to send the JUICE spacecraft directly towards Jupiter. That's why gravity assist has been used here. Now we know that the closer an object orbits to Earth, the lower its orbital energy will be, and the farther an object is, the higher its orbital energy will be. In the same way, all the planets also revolve around the Sun. Mercury is the closest planet to the Sun, so among the planets, its orbital energy is the lowest. It will be the lowest, and Neptune's orbital energy will be the highest. Before entering the orbit of any planet, it is necessary to match its orbital energy. When the Bepi-Bepi-Colombo mission was launched for Mercury, at the time of launch, its orbital energy was equal to Earth's orbital energy. But to enter Mercury's orbit, it had to lose its energy so that it could match Mercury's orbital energy, and to lose that energy, Bepi-Colombo had to do flybys around other planets. The reverse is also true. If we want to go into a bigger orbit, let's say Neptune or Pluto's orbit, then obviously their orbital energy is higher. So to reach there, our spacecraft will need that energy, and we will have to take, or you can say steal, that energy from planets like Earth, Mars and Jupiter. Now you might have this question. In both cases, that is, one is when we are losing energy and the other is when we need extra energy. So in both these cases, we are flying by the planets. So how can we gain or lose energy by flying by the planets? So the answer is relative motion. Yes, we can do this through the relative motion of the planets and the spacecraft. With gravity assist, we can speed up, slow down, and even change the direction of the spacecraft. If we fly by in the direction of the planet's orbit, the spacecraft gets a slingshot effect, which increases its speed. But if the spacecraft flies by in the opposite direction, its speed decreases. Here, according to Newton's third law, the momentum of the system remains conserved. This means that if the spacecraft's speed is increasing, then to conserve momentum, the planet's speed is decreasing. But the planet is a very massive object, so these changes become insignificant. You can also understand this whole process like this. If a spacecraft is withdrawing energy from a system, obviously that system is a planet, so the planet's orbital energy is decreasing. If the spacecraft is losing energy, then the planet's energy is increasing, because according to Newton's third law, the energy of this whole system should remain constant. But these changes are so insignificant that we ignore them. So the JUICE mission was launched from Earth, so just after launch, the orbital energy that the spacecraft has may be a little less or more than Earth's orbital energy. To reach Jupiter, JUICE will need extra energy because Jupiter's orbit is bigger than Earth's and it's farther away, so it will gain this energy. By doing flybys of Earth, Moon and Venus, and during this whole process, it's also important to make sure that it doesn't gain too much energy. Otherwise, its energy also needs to match Jupiter's, and that's the crucial thing making this mission's cruise time so long. After reaching Jupiter, it will do around 35 flybys of Jupiter and its moons. It will deeply study Europa, Ganymede, and Callisto, and its final focus will be on Ganymede. JUICE will become the first spacecraft to orbit a moon of another planet besides Earth's satellite, that is, the moon. The most crucial moment of this entire mission will be when the JUICE spacecraft, while orbiting Ganymede, slows down to 1 kilometer per second, and then it will be inserted into Jupiter's orbit. Inserting a spacecraft into orbit around any celestial body is extremely difficult. The spacecraft has to maneuver at a perfect speed, at a precise angle, at the right moment, and in the correct direction with the correct amount of force. Only then does the spacecraft get established in orbit. If the maneuver is done too fast, too slow, or at the wrong time, the spacecraft either crashes directly into the planet or gets lost forever in this infinite space. Then, even more effort can't correct the spacecraft's path. That's why the right amount of motion or the right amount of energy matters much more. That's why this mission will be able to reach Jupiter by 2031. Jupiter is the fifth planet from the Sun, with Mars ahead of it and Saturn behind it, both orbiting the Sun. Jupiter is a gaseous planet, which means it doesn't have a solid and rocky surface like Earth. It's completely made up of gaseous clouds. The composition of this planet is mostly made up of gases like hydrogen and helium. Therefore, scientists estimate that beyond its cloudy surfaces, deep inside, there is a place where boiling magma exists. Yes, Jupiter also has a liquid core, which drives the planet's extremely mysterious magnetic field. It is because of this planet's mysterious magnetic field that scientists have not been able to fully understand it to this day. So come, let's go together on this journey to Jupiter today and learn about the secrets hidden behind the planet Brihaspati. Jupiter is the fifth planet in the solar system, and it is a gas giant, meaning its structure is made up of a combination of gases. About 4.5 billion years ago, when the solar system was formed, certain conditions occurred that caused light gases like hydrogen and helium to move away from the sun, while dust particles moved closer to the sun. As a result, rocky planets with solid surfaces soon formed near the sun. Meanwhile, a little farther from the sun, beyond the asteroid belt, the planets we know today as gas giants were formed. According to researchers, gas giants like Jupiter and Saturn originated from the same gas cloud that once gave birth to our sun. Well, it was only after a long period of accumulation of these gases that these planets were formed. Space is a subject full of mysteries for humans, because till today, whatever we know or have heard about it, there is no scientific evidence available for any of it. Meanwhile, a great astronomer and scientist, Galileo Galilei, emerged in Europe. Galileo was the first scientist who started observing space with the help of mirrors and lenses. With the help of these lenses, Galileo made a telescope, and when he started studying space with his telescope, the first thing he observed was the planet Jupiter. It wasn't the first time that humans were observing this planet. Even before this, many ancient civilizations had confirmed the existence of the planet Jupiter in space. Whether it was the ancient Greek civilization or the Vedic culture of India, these ancient civilizations had described Jupiter in their own ways. But now, when Galileo discovered Io, Europa, Ganymede, and Callisto, which we now call the Galilean moons or Galilean satellites, and observed this planet through his telescope, he found that it was truly very fascinating and mysterious. Galileo not only discovered Jupiter, but also its four major moons, Io, Europa, Ganymede, and Callisto, which we now know as the Galilean moons or Galilean satellites. That was one era, and this is another. Over the past centuries, there have been many developments in technology. Today, humans have deployed extremely advanced space telescopes in space over the past decades. Thanks to these telescopes, we are now able to clearly observe distant galaxies. In such a scenario, interplanetary research has become much easier. For this purpose, many spacecraft have been launched, which have revealed many secrets of Jupiter to us. Whether it's Jupiter's mysterious magnetic fields or the extremely complex structure of this giant planet, we have truly succeeded in gathering information related to Jupiter. Therefore, even today, there are some mysteries related to this gas giant that scientists are continuously working to solve. Let's take a look at some of these unknown mysteries related to the planet Brihaspati. Mystery number 1. The presence of heavy elements on Jupiter is still a mystery to scientists. It was believed that Jupiter was also formed from the same hydrogen and helium cloud from which our sun was once formed. But recently, a research has emerged that questions this theory. In the past 5 decades, 6 spacecraft have studied Jupiter. Most of the time, the presence of heavy elements on Jupiter has been confirmed. However, when the same elements were searched for on the Sun, there was no evidence of their presence there. So how did these heavy elements end up on Jupiter when we didn't find those elements on the Sun, and it's believed that both of them were formed from the same cloud? To solve this mystery, we have to turn to NASA's Galileo. The team of scientists working on the spacecraft found in their observations that it might not be an inhabitant on Jupiter, but rather a comet or an asteroid. In this report, the scientists described how it gets pulled in by this force, eventually falling inside and merging with it. Therefore, this study rejects the previous theory. Recently, a new report has also come out in which scientists have suggested a completely different possibility. According to this new report, Jupiter was never actually born near the Sun. Instead, it originated from another cloud, which was about 4 times farther from our Sun's orbit. This new report has been prepared from the data collected by the Juno spacecraft. Mystery number 2, the presence of water on Jupiter. Water is the key to understanding how Jupiter formed. The asteroids and comets passing near Jupiter increased the presence of heavy elements on Jupiter. Along with this, the presence of hydrogen and helium on Jupiter was also significantly affected. A recent research has compelled us to find out to what extent the presence of water on Jupiter has been affected after such collisions with comets and asteroids. This happened in the year 1994. A comet named Shoemaker-Levy 9 system was moving towards the Sun at a very high speed. In such a situation, it encountered Jupiter on its way, and no one realized when this encounter turned into an accident. The intense tidal force completely destroyed it, breaking it into many small pieces. 20 years after this incident, recently, the Herschel Space Observatory performed an observation on Jupiter, and there, water was found scattered as a result of the breakup. No doubt, this water came from Comet Shoemaker and those fragments that fell on Jupiter, because higher traces of water have been found near the crash site of this comet. Even before this incident, scientists working on data coming from the Juno spacecraft made a surprising revelation. Good. The team had found a significant amount of water in Jupiter's atmosphere even before the incident. About 0.25% of Jupiter's total atmospheric molecules are water, that is H2O molecules, which was a much bigger number than previous readings, Jupiter's mystery number 3. The truth about Jupiter's core and understanding Jupiter's physics has always been a headache even for top space scientists. If we talk about Jupiter's composition, most of it, about 90%, is made up of hydrogen, and this hydrogen is present in Jupiter's upper clouds. Just like Earth holds gases like oxygen and nitrogen in its atmosphere, as we go deeper into Jupiter, the situation changes. Similarly, the pressure of hydrogen keeps increasing, and somewhere in the middle, there comes a point where we find a substance in liquid form. This substance can conduct electricity just like a metal. In a feature story presented by NASA in 2011, it was explained how Jupiter's liquid core affects its magnetic field. There are still many mysteries about the magnetic field of liquid pressurized hydrogen. Scientists are searching for these mysteries day and night, currently in orbit around Jupiter. Currently, Juno is focused on its core. For now, Juno's main objective is to find out the percentage of heavy metals present in Jupiter's liquid core. So last but not the least, mystery number 4. The truth about the storms and cyclones happening on Jupiter. Whenever we look at pictures of Jupiter, these striped lines and circles present in them often catch our attention. Actually, these are storms happening on Jupiter. In most pictures, we only get to see the top view of these storms. In such cases, no one can see beyond these clouds. The planet Jupiter is surrounded by its extremely dense atmosphere, which makes it very difficult to see inside it. For the past several years, the Juno spacecraft, which has been orbiting Jupiter, has been trying to find out what secrets are hidden behind the clouds of the planet Brihaspati. Data received from Juno has revealed that these storms, which appear as massive bands and circles, actually extend several thousand miles deep. Long-term study of the weather on Jupiter can reveal many secrets. Whether it's the reason behind the shrinking of the Great Red Spot, which has been raging for the past 200 years, or the precise demarcation of the compression point of the storms raging on Jupiter. If we want to uncover the mysteries of these planets, we will have to wait quite a while. In this context, some time ago, researchers from the world-renowned Stanford University were discussing this topic. That perhaps, even though they are millions of miles away from the Sun, possibilities of life can be explored on Europa, the moon of Jupiter, the 5th and largest planet in our solar system. Well, for your information, let me tell you that according to the International Astronomical Union, or IAU, where our Earth has only one moon, in complete contrast, Jupiter, or Brihaspati, has many times more moons. Altogether, this planet has a total of 95 moons. Out of these, the 4 largest moons, Europa, Ganymede, and Callisto, are known as the Galilean moons. Researchers suspect that there is a possibility of the presence of water on one of these moons, Europa. Friends, Europa is also called Jupiter's icy moon, and its diameter is slightly less than our moon, about 3,138 kilometers. It is the 6th largest moon in our solar system. Europa was discovered by Galileo Galilei in January 1610. German astronomer Simon Marius had discovered this moon at the time when Galileo was observing Jupiter's moons. That's why he is often also credited as the co-discoverer of these moons. Now, if we talk about Europa, friends, it's just like an icy world where for miles and miles you'll see nothing but ice and its rocky formations. And the conditions here are so dangerous that in just a few minutes, the freezing temperature would turn you into an astronaut popsicle. If we talk about human life, we know very well that Earth has an atmosphere, which is a mixture of different kinds of gases. This mixture contains about 21% oxygen, and this is the gas that keeps us humans alive when we inhale it. But if we talk about the atmospheric differences between Earth and Jupiter, it's important for you to know that while Earth has a very thick layer of atmosphere, on the other hand, Jupiter is so far away that its atmosphere is very fragile, so fragile that you would lose your life within just a few moments. In the images of Europa's surface, it's clearly visible that deep beneath its icy surface, various types of activities are happening deep inside, just like they do deep within the Earth. The effects of earthquakes caused by the collision of tectonic plates can be seen as dark-colored craters and spots. But one interesting thing to consider is that the kind of large craters we see on our moon are not seen on Jupiter's moon in the same way. Because of this, scientists believe that there must be something present deep below the surface, which even after meteor impacts helps this moon recover from them. But if we talk about the data, according to that, there is a good amount of oxygen on Europa. That means the oxygen humans need to survive is definitely present there. It's possible that life could exist inside the depths of Europa as well. Well, to learn more about this, NASA scientists constantly keep an eye on this moon and regularly add its activity to their research. But even then, you won't be able to breathe this oxygen because the pressure here is so high that you can't even take a breath. The reason why Europa is so interesting for scientists and astronauts is the possibility of liquid water existing beneath the sheet of white ice. By looking at some new images, we get more information about the marks and cracks on Europa, which NASA hopes to use. NASA believes that compared to any other body in our solar system outside of Earth, Europa has the highest possibility of microbial life existing. That means there could be some bacteria present even under very high pressure, which have not been discovered yet. If what they say turns out to be true, it will be a new achievement for science. After all, NASA has also planned to send a mission to land on the icy surface of the moon and drill through the ice shells into its oceans. However, it will still take quite some time for this to happen. Friends, if we talk about the deepest point on Earth, it is said to be about 10 to 11 kilometers, whereas the depth of Europa's ocean is a full 100 kilometers. Jupiter's gravity, attraction, pull, and Jupiter's elliptical shape. Due to the tidal energy generated in the orbit, there can be subsurface oceans here. To find out if there is actually something swimming around in the depths of this ocean, according to the images taken by NASA's Juno spacecraft, this planet, located far away from Earth, could become a new place where life could exist. Europa's crustal layer is completely covered with these large, frozen, icy rocks. But deep below, there is salty water, and researchers even claim that the amount of water present on Europa is much greater than that on Earth. According to scientists, Europa's frozen layer is about 20 to 24 kilometers deep, beneath which there is a deep ocean that may contain many mysterious living creatures. In addition, scientists have also discovered natural elements like carbon, nitrogen, oxygen, sulfur, and phosphorus on Europa. This year, NASA is going to launch a mission to Europa using a SpaceX Falcon rocket, which is considered one of its most powerful rockets so far. This mission will be called the Europa Clipper mission. However, NASA's Voyager 2 spacecraft, Galileo Orbiter, and Hubble Space Telescope have already carried out such missions. These are the ones completed so far. There are 3 or 4 such missions through which all the information about Europa and related discoveries has been obtained so far. If I explain in detail, friends, Voyager 2 spacecraft took some pictures of this moon for the first time during 1989, which revealed that Europa's surface is covered with lines and cracks. And because of these, scientists estimated that Europa might still be geologically active today. After that, missions were executed from 1983 to 2003, including during the Galileo mission. A lot of information was gathered from this. In September 2022, a spacecraft named Juno was just 340 kilometers away from Europa and took close-up pictures of its surface. It shared these with our scientists. In 2023, the JUICE mission will study Jupiter and its 3 icy moons: Europa, Ganymede, and Callisto. Europa Clipper will be the first spacecraft that is specially and entirely designed to observe Europa. As scheduled, NASA is expected to launch its Europa Clipper mission on October 10, 2024. After 6 years in 2030, by reaching the orbit of Jupiter's moon, the Europa Clipper mission will make dozens of flybys close to Europa. Europa Clipper is not just a mission to search for life. Its main objective is to confirm whether there are places beneath Europa's surface that could support life. For this, the spacecraft will orbit Jupiter and conduct close flybys of Europa to collect data on the moon's atmosphere, surface, and interior. While the Europa Clipper spacecraft itself won't be able to search for life, it will lay the groundwork for future missions. This spacecraft will pass very close to Europa. During this time, with the help of the instruments on board, scientists will work to gather as much information as possible about Europa's geological, atmospheric, and magnetic fields. Well, whatever the case may be, one thing is clear: the exploration of Europa is going to bring new challenges for scientists, whether it's dealing with extreme conditions or the demand for better technology. Sending a mission so far away from Earth will still require a lot of expense and effort. But one thing is certain: after overcoming every difficulty, we will know this for sure: whether there is really a possibility of life somewhere else besides our Earth. It's been almost 30 years since the discovery of the first exoplanet in 1992. In these 3 decades, the search for life on planets outside Earth has become much more intense. Space agencies and radio astronomers around the world are searching for nearby exoplanets where favorable conditions exist to host life. Scientists have named these planets super-Earths. Most of these planets are much larger in size compared to Earth. The studies conducted on these planets so far clearly indicate that either life already exists there, or we humans can sow the seeds of life on them. So let's take a journey through this dense, dark space where you and I together will witness these life-hosting exoplanets. At the top of this list is KOI 5715.01, a planet located about 1000 light years away from Earth. It is in a super habitable state to host life because all the factors needed to trigger the seed of life are present here, just like we see on Earth. Whether it's the presence of water in liquid form or oxygen gas flowing in the atmosphere, our observations and spectral studies so far indicate that this planet orbits its star. Observations and spectral studies indicate that life can not only emerge on this planet, but it can also thrive very well. Some scientists say it is orbiting in a habitable zone. Because of this, the temperature here is neither too high nor too low, which could be a major reason for the presence of liquid water on its surface. As we've told you many times before, humans' perception about life is highly subjective. Now, because we see life in creatures that breathe and have blood flowing through their veins, and who depend on their microbiology for their life. That's why whenever we go out in search of life beyond Earth, our perception is set on finding some microbial life form. The atmosphere of this planet is suitable for supporting life, and its star system is the right size to be a super-Earth. It is about 0.5 billion years old, which means its age is close to that of our Sun. Scientists estimate that it is about 1.5 times heavier than Earth and almost 10 times larger. The difference in size and mass between Earth and this exoplanet is actually a good thing in some ways. In fact, if the average surface temperature of this planet is 5 degrees Celsius higher than Earth's, then we would see extremely high biodiversity here. The species of living organisms found here would be present in much greater numbers. However, it is equally true that due to the presence of a massive planet, if its temperature is 5 degrees Celsius higher compared to Earth, then we would find areas of extremely high biodiversity here. The temperatures found here could also be comparatively much lower than Earth's. This could also become a major obstacle in the way of triggering life here. Now, the interesting thing to see is what turns out to be true among these two possibilities, or if there is something else. This newly discovered unknown planet. Your digital world, which people from all over the world are eagerly waiting to enter, and it's your responsibility to keep it secure. But I have an all-in-one solution for you. With one browser, you get secure, seamless browsing for your digital world. It opens it up because one browser is the must-have tool of 2024. With the built-in VPN, you can consume content from anywhere in the world and you don't need to install a separate VPN. Manage multiple accounts like LinkedIn, Facebook, Amazon. If you want to manage multiple accounts on any site with the help of one browser, there's no problem. Whether it's LinkedIn, Facebook, or Amazon, you can do it. You don't need to worry about suspension or verification. Just focus on your work and the browser will handle the rest. Apart from this, you can also share accounts with your colleagues without sharing passwords or dealing with the hassle of two-factor authentication. With one browser always by your side, it's easy and completely secure. Explore the digital world with one browser. It will save your time and also protect your accounts. Don't miss out. One browser is 2024's must-have tool. Try it now using the link in the description or pinned comment. Kepler 69c is about 2,700 light-years from Earth. Now it's time for an amazing world, an incredible exoplanet. On this 7-billion-year-old exoplanet, life is like a puzzle that just can't be solved. Caught in the struggle to find life. When scientists began researching extraterrestrial conditions for life, they discovered many surprising things. Actually, the emergence. When researchers related the biology of life forms present on Earth to the conditions of the cosmos, they found that if life is emerging or on the verge of emerging on any exoplanet in this universe, then the age of that planet should be at least 5 billion years, and at most, that planet could be as old as 8 billion years. Behind these numbers, there is an amazing calculation hidden, and at most, that planet could be 8 billion years old. It would be in a stage of continuous transformation and evolution. Just like the Earth was born about 4.5 billion years ago, and for many hundreds of millions of years after its birth, it remained in a continuous stage of transformation and evolution. During this time, sometimes its surface was dominated by gases like hydrogen and helium, sometimes massive volcanoes erupted here, sometimes the ice age froze everything, and sometimes the ice on its surface melted. In the end, the dry land turned into seas and oceans. The birth of life on Earth is itself the result of a very long and extensive process involving the formation of seas and oceans. Hence, it's proven that from the Big Bang explosion about 13.7 billion years ago until today, if life has developed on any planet, it would exist within this window of 5 to 9 billion years. Well, if we talk about Kepler 69c in terms of size, this planet is about 4 times bigger than our Earth. Now the question here is, how can life develop in such a massive planet to this extent? On such a massive planet, there would be a huge continent with a scorching desert in the middle, and far away at the edges, the ocean would surround the land from all sides. Because of its extremely large size and mass, this planet would have a strange kind of geography, and such places would exist on this planet, where the conditions for life could be favorable, whether it's water flowing in a liquid state on the surface or something else. Continuous research on the planet is being conducted on a dense atmosphere that maintains air pressure and the movement of gases. Research is ongoing on this planet. Every day, scientists are working on this. They are optimistic. They believe that if they use powerful and precise observatories like James Webb in their further studies, the results could be even more encouraging. Kepler 1126b has secured the 3rd place in the list of planets that could potentially sprout life. Its name is somewhat similar to Kepler 69c. This exoplanet, located 2073 light-years away from Earth, seems to meet the criteria for supporting life. Yes, it is 7.5 billion years old. That means 7.5 billion years. It's ancient. This planet orbits a yellow dwarf star just like Earth orbits the Sun, although the difference is that this planet's host star is not exactly like Earth's Sun. In comparison, yes, because it is less hot, its Goldilocks zone, or you could say its habitable zone, is much closer compared to our Earth-Sun system. Hence, even though it orbits so closely, this planet is still in the star's habitable zone. However, till now, scientists have not performed any detailed study or research on it. Because of this, we still don't know about its structure. Till now, we don't know this. Is this planet really not a rocky one? Let's find out. This exoplanet named Speculus 2c is located at a distance of only exolight years from Earth. It's really quite close, although even with this short distance, it's still very far for us. Even if we travel at the fastest speed ever achieved by humans in space, it would still take 200,000 years to reach here. Seriously, this journey is so long that it's impossible to even imagine. You will be surprised to know that it's only been 200,000 years since the entire human race came into existence. Even if we set out for that planet tomorrow, it would take us just as many years to get there, and that too irrespective of realities. Anyway, contrary to these things, Speculus 2c is actually an optimistic world. About 40% larger than Earth in size, this planet is undoubtedly a rocky planet. Like Earth, its surface is also made up of solid rocks. By the way, it is in the habitable zone of its star. Its star carries only 15% of the mass of our sun. This is the reason why other planets are orbiting it from a very close distance. At such a short distance, it also brings an unwanted possibility, and that is tidal locking. Yes, it might be possible that Speculus 2c is tidally locked with its parent star. And if that's really the case, then surely this is going to be bad news. Because if that happens, one side of this planet will always face its sun, while the other side will always remain in complete darkness, which will create a massive temperature difference here. This is not a good sign for the planet's ability to support life. Anyway, out of all these exoplanets, which one do you have the most hopes for? Be sure to share your opinion with us in the comment section. If you like this video, be sure to share it with your friends. And to keep watching more videos related to space and astronomy, make sure to subscribe to our channel. Friends, we'll meet again soon with another new video. Until then, thank you.